Let's graph transform cotangent. Let's say we're going to graph f of x equals the cotangent of 2 times x plus pi. All right, so we have two transformations going on. First thing I'm going to do to graph cotangent is I'm going to rewrite it in terms of sine and cosine. Now we know cotangent is cosine over sine. We're going to keep the transformations intact. So we're going to have the cosine of 2 times x plus pi divided by the sine of 2 times x plus pi. And what we're going to do is we're going to use the points for parent sine and parent cosine after we transform them, and help use those points to help us graph our transformed cotangent. So let's just talk about these transformations here a minute. So we have left pi radians, and we also have a horizontal shrink by a factor of 1/2. So I'm going to take our anchor points, 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to shrink them first by a factor of 1/2. So it's going to give us 0 pi, pi over 4, pi over 2, 3 pi over 4, and pi. And then we're going to shift them to the left pi. So it's going to give me negative pi, 1/4 minus 4/4, negative 3 pi over 4, 1/2 minus 1, negative pi over 2, 3/4 minus 4/4, negative pi over 4, and then pi minus pi is going to give us 0. Okay, so these are going to be those transformed x values that I'm going to use to graph my transformed sine and my transformed cosine. So let's kind of set up our scale here. So I'm going to count by pi over 4s. So I'm going to have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. That'll be pi. Negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative pi. Okay, so again, we're talking cosine of 2x plus pi over the sine of 2x plus pi. Now I'm going to start with the denominator. Where the denominator equals 0, cotangent's going to have vertical asymptotes. So I'm actually going to use my pencil. I'm going to use my pencil to go here and graph my transformed sine. So at negative pi, sine would be at the center line. At negative 3 pi over 4, it would be at the maximum. At negative pi over 2, it would be at the center line. At negative pi over 4, it would be at the minimum. And at 0, we'd be back at the center line. I'm going to do another forward period. So max to center line to min to center line. Now, I'm using my pencil because I'm going to erase some points here. I don't really care where sine is at the max or the min. I'm only concerned with using sine to help me figure out where cotangent is going to be undefined. So again, where sine is on the center line, cotangent is going to have a vertical asymptote. So at negative pi, at negative pi over 2, at 0, at pi, at pi over 2, and at pi, cotangent is going to have a vertical asymptote. All right. Now, let's talk about the numerator. Where the numerator is equal to 0, that is where cotangent is going to have roots. So think about the behavior here for cosine. At negative pi, we know cosine is at the max. Negative 3 pi over 4, it would be at the center line, so that's going to give me a root for cotangent. Negative pi over 4 would be at the minimum. That's negative pi over 2, we're at the minimum. Negative pi over 4, we're back at the center line, and at 0, we would be back at the maximum. So basically here, halfway between every vertical asymptote, cotangent is going to have a root. Now, the only thing asked to do is remember that cotangent is a decreasing function. So he's just going to come down, decrease down that vertical asymptote. As x increases in between those vertical asymptotes, the y values are going to decrease, and y is going to look like basically a decreasing cubic function in between its two vertical asymptotes. And there you have it. That would be 4 periods of our transformed cotangent function.